In this video, you will learn about powers of monomials. Now, with powers of monomials, there are two main rules that you need to know. The first rule is the rule of exponents for a power of a power. So what that would look like is something like this, where we have x to the fifth power, and then we raise that to the third power. So we have a power to a power. The fifth power is raised to the third power. So how this works is we would have 3 of these x to the fifth powers. So that can be written as x to the fifth times x to the fifth times x to the fifth. Well, with multiplication, we know that we add the exponents 5 plus 5 plus 5 to get 15. Now, we don't want to have to write this out every time where we expand and have to do this middle step. We want to know how to get from here over to here directly. So to do that, I look at the exponents. I have 5 and 3. If I multiply those together, I get 15. So the rule says that if I have a power to a power, I multiply the exponents. So in math notation, you see here, a to the m power raised to the n power. What that means is we keep multiplying a to the m over and over again until we do it n times. All right, so we do it n times. And then to simplify, we have to add all those m's together. So we take a and then raise that to the m, etc. And the number of times we add would be n times because there are n terms. So the simpler way to write addition, if you're adding the same thing over and over again, is we can multiply the two numbers m and n together to get m times n. So in math notation, the rule says a to the m power raised to the n power, you would multiply to get a to the m times n power. So as we stated in English, to find the power of a power, you simply multiply the exponents. So here's an example. We have a cubed and raised to the fifth power. So what I do, because I have a power to a power, is I multiply the 3 times 5 to get 15. So that would be a to the 15th power. Here we have negative y to the third power, and then raise that to the sixth power. So we have a power to a power, which means we multiply 3 times 2 to get 6. So I have negative y to the sixth power, and that would actually be the same thing as positive y to the sixth power, and this would be a simpler way of writing. And y is equal to y to the sixth power is because negative y to the sixth power means you take negative y times negative y times negative y, do that 6 times. That's 4, 5, put another one in the front, 6. So when you multiply all these negatives together, you have negative times negative, which is positive. 2 more negatives make a positive, 2 more negatives make a positive. So here, this becomes a positive. So we have positive y to the 1, 2, 3, 4, 5, 6 power. So this is a better way of writing it because the negative multiplied over and over again would become a positive. So if the exponent is even, it's going to be a positive. If the exponent is odd and it's a negative number, then this would be a negative. Next, we have our second rule, and that is for a power of a product. So for example, if you had more than one thing in parentheses and we have an exponent outside, what do you do in this situation? So bottom line, this exponent is going to go to everything here in the parentheses. We would have 3 squared and x squared. Now we can prove that because 3x squared means we have 3x times 3x. And so 3x times 3x, we can multiply the 3's together and multiply the x's together to get 9 times x squared. All right, so we have proven that this would be true because like I said, the rule says we can take the exponent and put it with everything in parentheses. So we have the 3 squared and the x squared. So 3 squared would be the 9, and then x squared is x squared. So in general, here we see it in math notation, where we have two numbers in parentheses, a times b, and that is raised to the m power. So what that means is that I multiply ab over and over again, and from here I put the a's together and the b's together. So then a, the number of times I multiply the a's together, would be m times, and for the b's, same thing, I multiply it m times. So I have a to the m power times b to the m power. So the rule stated here in math notation is ab to the m power equals a to the m times b to the m power. And as we stated in English, when you have a power outside of parentheses, you raise everything in parentheses to that power. So here we see negative 2c to the third power. This one we take negative 2 to the third power and then c to the third power. Negative 2 to the third power would be negative 2 times negative 2 times negative 2, which would be negative 8. And then we have c cubed over here. Alright, here we're going to evaluate, and we're doing the same thing, but we're just plugging in numbers first. So if you had 3x cubed, and you were told to evaluate if x equals 3, I put the 3 in here with the x. So this becomes 3 times 3 to the third power. 3 to the third power is 3 times 3 times 3, which is 27. So I have 3 times 27, which would be 81. Now another example, we have the entire quantity of 3x raised to the third power. So I begin by plugging in the 3 in for x. So I have 3 times 3 in parentheses. And I mean, two ways you can do this, but you could take the 3 for the exponent, put it with this 3, and then put it with this 3, and then put them together. So if you wanted to, you could write this as 3 cubed times 3 cubed, and then simplify from there. And that would be 3 times 3 times 3, that's 27 times 27, and whatever that is equal to. The other way is you could just multiply 3 times 3 to get 9, and then raise 9 to the third power, which would be 9 times 9 times 9, which would equal 729. And that is the same thing you would have gotten over here. Okay, another example, we have 3 cubed times x cubed. So we plug in the 3 in for x, so we have 3 cubed times 3 cubed. Well, 3 cubed is 3 times 3 times 3, which is 27. And then we have another one of those, so 27 times 27, and that would also equal 729. Now just one more example. Here we see negative 3x cubed, y to the fourth, and then all that is raised to the third power. So here we need to raise everything in the parentheses to that third power. So I have negative 3 to the third power, I have x cubed to the third power, and I have y to the fourth to the third power. Now from here, we have to use that first rule that we discussed in this video, where for the power to a power, we need to multiply the exponents. But here at the beginning, negative 3 to the third would be negative 3 times negative 3 times negative 3, which would equal a negative 27. So that is negative 27. And then x to the third power. We have a power to a power, so we multiply 3 times 3 to get 9. So that would be x to the 9th power. And then the y's, we have y to the 4th power to the 3rd power. So power to a power, I multiply 4 times 3 to get 12. So I can have my final answer as negative 27 times x to the 9th times y to the 12th power.